ladies and gentlemen. Let us discuss the general ability part, the 10 questions of general ability part of electronics and communication engineering portion of GATE 2022. So in front of you in the slide, you can see the first question that was there. A sum of money is to be distributed amongst P, Q, R, and S in the proportion 5:2:4:3 respectively. If R gets rupees 1000 more than S, what is the share of Q in rupees, of course? So how do we approach this? We use simple ratio and proportion fundamentals. We say that because P, Q, R, and S are in the proportion of 5:2:4:3, so P can be said to be having 5K amount of money. Q can be said to be having 2K amount of money. R can be said to be having 4K amount of money. And S similarly 3K amount of money. Now R gets 1000 more than S. So we can say that 4K minus 3K is equal to 1000, which means that K is nothing but 1000. So they have asked you what is the share of Q. Now Q is 2K, which means the share of Q is 2 into 1000. That is rupees 2000. And hence we tick option B. The next one. A trapezium has vertices marked as P, Q, R, and S in that order anti-clockwise. The side PQ is parallel to side SR. Further, it is given that PQ is 11 centimeters, QR 4, SR is 6 centimeters, and SP is 3 centimeters. And they have asked you what is the shortest distance between PQ and SR in centimeters. So let's first draw a random trapezium. A random trapezium would look somewhat like this. Let us mark the sides. See, we have taken these two sides as the parallel ones. Let us mark the sides. See, P, Q, R, and S are in anti-clockwise direction. So let us suppose this is R, this is S. So this must be P and this must be Q. See, P, Q, R, S in the anti-clockwise direction. PQ is 11, so this portion is 11. QR is 4, RS is 6, and SP is 3. Okay, so this is it. Now, the shortest distance between PQ and SR will always be the perpendicular that joins these two parallel lines. So let us construct two perpendiculars. One starting from S on PQ and another starting from R on PQ. Let us name them as say M and N. So because SRNM is a rectangle, both the sides are parallel, see, and these two lines SM and RN, since they are perpendicular to the same straight line, must also be parallel to each other. Hence, all the four lines are parallel to each other and there is a right angle in between them. So this must be a rectangle. So we can say that since SR is 6, so MN must also be 6. Now we can say that instead of 11, we can write MN as 6. Let us assume, say suppose NR, that is the length of the perpendicular, as X. Let this be X. So this is also X. And let us assume NQ as Y. Now because NQ is Y, so we can say now that PM is 11 minus 6 plus Y, which is nothing but 5 minus Y, right? Well, we should not forget that these are two right-angled triangles. So Pythagoras theorem is very much applicable in them. Let us apply Pythagoras theorem to triangle RQN. So from RQN, we can say that 4 square is equal to x square plus y square. So this is one relation that we get. Let us now consider triangle SPM. So from triangle SPM, we can say that 3 square is equal to x square plus 5 minus y whole square. On expanding this, or rather writing this properly, we can say that x square plus 25, that is 5 square, plus y square minus 10y is equal to 9, or rather x square plus y square minus 10y is equal to 9, is equal to minus, my apologies, is equal to 25 goes on to that side, so is equal to minus 16. We can say that. Now substitute the value of x square and y square on this side. If x square and y square is 16, so we can say 16 minus 10y is equal to minus 16, or rather 10y is equal to 32, and hence y is equal to 3.2 centimeter, because they are all given in centimeters. So we have found out the value of y. So our remaining job is to find out the value of x, which we can do from this part. X square plus 3.2 whole square is equal to 16. 3.2 whole square, we can say this is 4 square actually instead of 16. See, we in the exam hall, we should not try to find out 3.2 whole square, because that would be cumbersome. So rather than that, you see x square is 4 square minus 3.2 whole square, which we can say is 4 minus 3.2 into 4 plus 3.2, which gives us, see, this is 0.8 multiplied by 7. Now this is far more easier, right, to calculate. So 8 2s are 16, 7 8s are 56, 56, and 1 is 57. So it would be 5.76, which is our answer. Got it. So that's the trapezium one. Let's go on to the next. The figure, as shown below, shows a grid formed by a collection of unit squares. The unshaded part of the unshaded unit square in the grid, that is this whitish portion, represents a hole. What is the maximum number of squares without a hole in the interior, that can be formed within the 4 into 4 grid? See, I hope you understand this is a 4 into 4 grid, right? Using the unit squares as building blocks. So how do we consider this? Very simple. First, let us consider this part of the block. See, notice the part that I am trying to highlight. See this. The artistic thing might not be exact, but I hope the understanding can be made from here. Let us do this. Now, you will agree that this is a 2 into 4 grid. So in this yellow one, let us find out how many squares can be present. So the number of squares that can be present is, see, 4 into 2. So it would be 4 into 2. These are 1 into 1 dimensioned squares. And if we consider the 2 into 2 dimensioned squares, so you see 1, 2, and 3. So 3 into 1, right? So 3 into 1, 2 dimension squares. So the total number of squares will be this one, which is 8 plus 3, that is 11. Correct? Now let us do a little bit more of shading, and let me choose an appropriate color for that. Okay, let us shade this portion. Well, it has become a bit deeper than I would have liked, but I hope it is understandable. So let us understand what this is. Now, this also you will agree, this I would mark as the blue one. This is also a 4 into 2 grid, right? The previous one was a 2 into 4. This is a 4 into 2 grid. And hence the number of squares I can say would be 2 into 4 plus 1 into 3. So that is 11 squares in this blue portion. But then, ladies and gentlemen, do consider that greenish part, the greenish part which is there here, which is the common part of the yellow as well as the blue, the green one. This green one is common to both, right? So let us find out how many squares are there in the green one. Obviously, this is a 2 into 2 grid, so the number of squares would be 2 into 2 plus, if you take the 2 into 2 dimensions, then 1 into 1 squares, which means 4 plus 1, that is 5. Now let us take the remaining part. The remaining part would constitute this portion. See, this part. Let us not forget that the whitish part is a whole. So we are considering this portion. And well, I would say this is light green. So let us consider the light green portion. Now there, if you notice carefully, you cannot take into accountability the number of squares as we found out for a grid, because it's an independent sort of a stuff. So the only number of squares present will be 1 into 1, which is 3, right? So let us now find out the number of squares which do not have a grid in them. This does not, do not have a hole in them, right? So this does not have a hole in them. Neither has the blue part. So 11 plus 11. But then the green part is common to both. So I am calculating this 5 squares double times. So just keeping in mind the theory of Venn diagrams or set theory, I will subtract it once. So this constitutes the yellow, green, blue, and this portion plus these 3. Let us see what it comes to. 11 plus 11 is 22. 22 minus 5 is 17. 17 plus 3 is 20. And hence there will be 20 small units. So that's how we would solve this one. Let's go to the next one. This appears to be a logical reasoning question. Let us see what has been said. An art gallery engages a security guard to ensure that the items displayed are protected. The diagram below represents the plan of the gallery. See, this is a sort of an odd sort of gallery, concave sort of, a concave quadrilateral, you might say. Below the plan of the gallery, where the boundary walls are opaque. The location the security guard posted is identified such that all the inner space is the shaded region of the plan of the gallery, is within the line of sight of the security guard. If the security guard does not move around the posted location and has a 360-degree view, so he is not moving, but he can look all around him, which one of the following correctly represents the set of all possible locations. Among the locations P, Q, R, and S, where the security guard can be posted to watch over the entire inner space of the gallery. Now, this is absolutely common sense, I should say, that if the security guard were posted at P, he wouldn't be able to see this portion because his line of vision would be obstructed by these walls. Same for R if the security guard were posted at, was positioned at R. So he couldn't see this portion. His line of sight would be blocked. But then if the security guard sat at Q, he could see all around him. Everything was visible. And so would be if he were positioned at S. So I would say Q and S must be the position of the security guard. And I would pick this. This was a simple one. Okay, this is a verbal ability question. Mosquitoes pose a threat to human health. Controlling mosquitoes using chemicals may have undesired consequences. In Florida, authorities have used genetically modified mosquitoes to control the overall mosquito population. It remains to be seen if this novel approach means new approach, has unforeseen consequences. Unforeseen means consequences which you haven't seen beforehand. New consequences, unforeseen consequences. So which one of the following is the correct logical inference based on the information in the above passage? So this is a critical reasoning question. Let us observe the options. Using chemicals to kill mosquitoes is better than using genetically modified mosquitoes because genetic engineering is dangerous. Now, in critical reasoning, whatever is said in the passage has to be the source of our information. We can't add any information or, give our own judgment. Now, nowhere in the passage has this been written. So obviously this can't be the correct logical inference. Inference means conclusion. Can't be the logical conclusion of the question. Using number B, using genetically modified mosquitoes is better than using chemicals to kill mosquitoes because they do not have any side effects. Well, this is an absolutely wrong statement because in the passage it has been said that this is a novel approach and we don't know about its consequences. So how do we know that they do not have any side effects? Side effects and consequences are the same thing. So this would also not be the correct one. Next, both using genetically modified mosquitoes and chemicals have undesired consequences and can be dangerous. Well, our say would be that nowhere it has been said so. How can we conclude this unless it has been already previously understood? So it has been said so because using genetically modified mosquitoes, the consequences we do not know as of now. So this is also wrong, which leaves us with the remaining, which has got to be the true. But here, let us, in the exam, I would have clicked that, but here, let us study that also. Using chemicals to kill mosquitoes may have undesired consequences. But it is not clear if using genetically modified mosquitoes has any negative consequence. Now, this is exactly what has been said. See, controlling mosquitoes using chemicals may have undesired consequences, which is exactly what has been said here. It is not clear if using genetically modified mosquitoes has any negative consequence. That is exactly what is being said here. So naturally, we will say this is the correct logical information, but conclusion that is based on the above paragraph. Consider the following inequalities. 2x minus 1 is greater than 7 and 2x minus 9 is less than 1. Which of the following expressions below satisfies the above two inequalities? Let us do them. Let us take the first one. From the first one, I hope we all can understand that 2x is greater than 8 and hence x is greater than 4. And from the second one, I am sure we can equally understand that 2x is less than 10 and hence x is less than 5. So we would say that x must be less than 5 but greater than 4, and hence we will say this is the right option. Simple problem. 4 points. This is based on coordinate geometry. 4 points P, coordinate 0, 1, Q, 0, minus 3, R, minus 2, minus 1, and S, 2, minus 1 represent the vertices of a quadrilateral. So they have asked, what is the area enclosed by the quadrilateral? Now, normally we have a tendency to assume that, okay, they have given PQRS. So these vertices must appear in alphabetical order. And most of us would maybe say, suppose this is a quadrilateral, would have said this is PQRS, or maybe anticlockwise. Someone who would prefer anticlockwise also, and would have said maybe either this or this would be the quadrilateral, and hence these would be the coordinates of those vertices. Never fall into that trap. Always, if ever you get any dimensions of the quadrilateral or triangle or whatsoever. Triangle is easy because only 3 are there, so you don't need to do anything. But quadrilateral or for any higher, what shall I say, a two-dimensional figure, always verify. So how do we verify here? See, a bit of common sense. In this coordinate system, 0, 1 would be somewhere here. Okay. 0 minus 3 would be somewhere on this side. So mind it, if this is P, then this becomes Q. Now minus 2 minus 1 would be somewhere around here, right? So this would be R, and 2 minus 1 would be somewhere here, right? So this would be S. So if we notice carefully, the examiner has given the quadrilateral in the form of PRQS if taken in the anti-clockwise sense, or PSQR if taken in the clockwise sense. And hence the coordinates would be coming in this order. Most of us would make a mistake in this particular stuff. So we should always be a little bit careful about this thing. So this is it. Now the first thing has been overcome, challenge has been overcome. Now the second challenge, how to find the area of a quadrilateral in case of coordinate geometry. It's very simple. See, the area of this quadrilateral PSQR would be given by half of a determinant. What is the determinant? See, choose any vertex. Let us suppose you choose P. Consider the x-axis portion, that is 0. Take the opposite one. So the opposite vertex is Q. That is also 0 x-axis. So subtract that. Likewise, take any one of the other vertices. Say for example R. So that x value is minus 2. And then take the remaining one which is opposite to R. That is 2. So minus of 2. That is minus 2. Now this is the x part. Do the same with the y part. So P's y is 1. And here it is minus 3. So 1 minus of minus 3. And here we had taken r first, so that would be -1 and minus of +1, rather minus of -1, that is +1, which makes this thing the simple 0, 4, and here would be -4, 0, right? Now the evaluation of this is absolutely simple. See, this is half into 4 fours are 16, okay, and 0 minus of -16, that is 16. So we can write 16 plus this sign acts as the modulus. Even if it had come in the negative, we would have written +16. So this is 8, and hence 8. Units haven't been given. So 8 units is the area, and we will be taking this. So this is the point to be careful about. And then, of course, how to find the area? This is the shortest way by which we can find the area of any quadrilateral in coordinate geometry. Let's go on to the next one. This clearly looks as a logical reasoning question. Let us see. In a class of 5 students, P, Q, R, S, and T, only one student is known to have copied in the exam. The disciplinary committee has investigated the situation and recorded the statements from the students as given below. Statement of P means person P said R has copied in the exam. Q says S has copied in the exam. R says no, P did not copy in the exam. S says only one of us is telling the truth. T says R is telling the truth. The investigating team had authentic information, correct information, that S never lies. S will never lie. So we know for sure that S is telling the truth, right? And what is the truth S is saying? S is saying that only one of us tells the truth. So who is that one of us? Who is that only one of us? It must be S himself, right? Because we all know that S never lies. So if S is saying the true statement that only one of us is telling the truth, that one must be S himself. Okay. Now, what have they asked? Based on the information given above, the person who has copied in the exam is who? Now P is telling a lie. R has copied in the exam. So R hasn't copied in the exam, right? Q is telling a lie. S has copied in the exam. So we know for sure that S hasn't copied in the exam. R is telling a lie that P did not copy in the exam. So then what is the truth? P copied in the exam. The truth must be P copied in the exam from this statement, because R always tells a lie, right? So our job is done. P copies. Based on the information given above, the person who has copied in the exam is P, right? I hope we have understood this. Next, consider the following square. This is another logical reasoning portion. Consider the following square with the 4 corners and the center marked as P, Q, R, S, and T respectively. So the corners are P, Q, R, and S, and the center is marked as T. Now, the center of a square is always the intersection of the diagonals, right? So X, Y, Z, let them represent the following operations. What does operation X mean? Rotation of the square by 180 degree with respect to the SQ axis. Means with respect to the XQ axis, very difficult to show in a 2-dimensional. Means you move it like this, 180 degree. So that is operation X. Y. rotation of the square by 180 degree with respect to the PR axis. So y would be somewhat like this sort of a rotation. Okay, explaining this in a two-dimensional is a bit difficult, but I hope you can understand. And let us see what z is. Rotation of the square by 90 degree clockwise with respect to the axis perpendicular, going through the screen and passing through the point P. Means through T there is a point passing, something like this. It goes like this, I hope you understand. I can't draw something coming towards you, but this is it. So that way, clockwise, Z will move clockwise. So that is Z. Let us cancel this axis, because I presume we have understood what the axis is, and this is going to create unnecessary problems. So that is it. So this is X, Y, and Z. Now consider the following three distinct sequences of operations which are applied in the left to right order, which means first X, then Y, then Z, and then a second time Z. The second option is first X, second Y. And the third is 4 times you apply Z. So let us see X, Y, Z, Z, what will be the stuff. First, I am applying X, Y on this square. I am applying X on this square. So X means I am rotating 180 degree along S cube. So now R will go on this side. So this will be R, this will become P, and this will remain the same. Then I will do a Y on this. Now I am not going to do the Y on the main diagram. I am going to do the Y on this, what I have achieved just now. So Y means what? Along this axis, I shift 180 degree. So Q will come up here, S will come up here, and the rest will remain as it is. So this is, I have done a Y on this. Then on this, I will do a Z. Means I will move 90 degree clockwise, means only one step. So the first Z would mean that see, R comes here, S comes here, P comes here, and Q comes here. And I would perform Z the second time. See, we could have said together that twice you are applying Z, so it would be a 180 degree change. But one doesn't know where they will be the same. So as a dint of this, I'm showing you every step. So the next case would be, this would be R, this would be S, this would be P, and this would be Q. So this is the final stage. Okay. Now let us go on to do X, Y. So there is no space below, so let us do it here. So let us first apply X on the main diagram. Now we know what happens when X is applied on the main diagram. We do not need to think it again. So we have already done X. So we just apply it. Then you do another Y. So that also you know what happens. So there was nothing needed to think about the second option, because that was ready-made. We had done it ourselves. So X, Y, this would be the end one. This is the end one in the first. This is the end one in the second. Let us do Z, 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 Z. I'm sure you will all agree about one thing. See, one ZP becomes here. Second ZP will become here. Third ZP will become here. Fourth ZP will become again here. Means after applying all the 4 Z's, we will get back the original cube, original square in its normal form. I hope we all understand that. This is Z applied 4 times rather. I hope we all agree on that. Now let us see what has been asked in the question. Which one of the following statements is correct as per as the information provided above? The sequence of operations 1 and 2 are equivalent. They can never be, because as you can see, the end products are different. RS PQ, while this is PQ RS, so it's not so. The sequence of operations 1 and 3 are equivalent. Now here we will say it's absolutely so. PQ RS, PQ RS. So we will say this is the right one. Let us check what the others are. The sequence of operations 2 and 3 are equivalent. They can never be. 2 is this and 3 is the different one. And the sequence of operations 1, 2 and 3 are equivalent, which is obviously not as this. So we got the correct answer. And that's the end of this part. Thank you, ladies and gentlemen. Let us end this session here. This was actually question number 1, and it says, and this is as you can see, a verbal ability question, which says that, just hold on. Yeah, Mr. X speaks dash Japanese dash Chinese. So here the correct option would be Mr. X speaks neither Japanese nor Chinese. He doesn't speak either, so that is given in this form. So neither Japanese nor Chinese would be our right option that we should pick here. So this was the question that was left. Thank you very much.